can we prepare alkyl halides from alcohols? Remember that this has been a recurring topic in the last few lectures, is that OH is not a good leaving group per se. So what we have to do is to take that OH, convert it into a better leaving group, and then react it with the nucleophile that we want to substitute in there where the OH is. So the way that this reaction is going to happen is not with the OH, the simple OH as a leaving group, but once the OH gets protonated by that H in the hydrogen halide, we form this water that now it's a really good leaving group, and now the halide that left in the first step now can come back, attack the R, and the water leaves as a good leaving group, and that's how we get the alkyl halide. So remember, the reaction with the water with the OH minus is not going to react because OH minus is not a good leaving group, but once we make it a good leaving group, then the reaction can happen. So the most common way to do that is to react it with HBr, HCl, or HI. Remember that HF is not very acidic and therefore is not going to help us here protonating that water. So we will compare the different mechanisms when we have a primary, a secondary, or a tertiary alkyl halide. This is the general mechanism that I just talked about. So we have the OH minus that will come and get the hydrogen, and then the X minus will leave. The first step is a proton transfer. Now we have the water as a good leaving group, and then we have a good nucleophile, that's the halide that just left, and then the next reaction can either be an SN1 or an SN2 depending on the substrate that we are talking about. So let's talk about what happens when we have a primary alcohol. When we have a primary alcohol, the reaction will happen through an SN2 mechanism. OH will come and get the proton, so that will get protonated. The Br minus can leave, and now the Br minus, that is a good nucleophile, will displace the water. Remember that this carbon right here is not chiral, and therefore there is no inversion of configuration. But if the carbon that it's attacked were to be chiral, then yes, we will get an inversion of configuration because this is an SN2 mechanism. Now, when we have secondaries and tertiary alcohols, the reaction will go through an SN1 mechanism. The first step is the same one. The alcohol gets protonated, the Br leaves, and now we have water as a good leaving group. And because if water leaves, we get a stable carbocation, that's a tertiary carbocation, it will form, and now the Br can come and attack. And remember that in this particular case, we will get a mixture of the Br attacking from the top and the Br attacking from the bottom. In this case, that doesn't matter because this carbon right here is not chiral, but it will matter from now on if that reaction happens in carbon that is chiral. The reactivity of the hydrogen halides increases as the acidity of the hydrogen halide increases. So remember, HI is the more acidic of them all because I is large and it's okay stabilizing the extra electrons. Now, when we talk about, that was for acids and bases, but when we talk about nucleophilicity, remember that Cl is a poorer nucleophile, than Br and I minus. Remember that Cl minus is smaller and it's not polarizable. You can refer to previous videos to review that. So Cl minus is a smaller molecule, and Br and I are larger molecules. Because they are larger, they are more polarizable, and therefore they can be better nucleophiles. So what we have to do in the case when we want to make alkyl chloride is we have to complex it with this zinc chloride complex, and then that will make it a better leaving group. So what happens here is that the zinc chloride is a Lewis acid instead of being a Bronsted acid. So now the lone pair on the oxygen will attack that Lewis acid. Now this is a good leaving group, all of it together. And now the Cl minus can come and attack in an SN2 fashion. I talked about it. So when we have a primary alcohol, then we will get inversion of configuration when the carbon that we start with is chiral. And the same goes for a tertiary alcohol. When we have a tertiary alcohol and it goes through an SN1, we will get a racemic mixture. This is exactly the same that you've seen in previous videos. So remember, SN2 will give us inversion of configuration and SN1 will give us a racemic mixture.